Hello and welcome to the sixth session of my lecture, Example 2 of Bending Members. In this example is the same as the example 1, but the difference is the compression flange is not laterally supported. The first step is to find section properties. You can find section properties on chapter 6 of the handbook, and this particular one is on P648. Now you have to find the class of the section. In order to find the class of the section, you have to find the class of each component, and the bigger one will be governing one. Okay, so the first component is flange. B over T is equal to 167 over 2 over 13.2, which is thickness of the flange, is equal to 6.3. Then we know that B over T is equal to X over square root of Fy. The benefit of doing this is that we can find X and then go to the tables, which is P2.24. In these tables, you can find out by comparing X to the conditions, you can find out which section is your component. So X is equal to 117.9. Therefore, B over T, which is equal to 117.9 over square root of Fy, will be lower than 145 over square root of Fy. We conclude that flange is class 1. Now we're going to the second component, which is web. H over W, which is thickness of the web. The way we calculate H is the height of the web, so we have to say D minus 2T, which is 2T is the thickness of the flange. We want exactly the height of the web, over 7.6, which is thickness of the web. It will be equal to 3.2, and then we can find the H over W is equal to X over square root of Fy. X will be equal to 714.7, and then if we look at the table, P224 H over W is equal to 714.7 over square root of Fy, lower than 1100 over square root of Fy. Therefore, web is class 1. Now we can conclude that section is class 1 because all the components are in class 1. Okay, in order to calculate the moment resistance, first we need to find MP. Plastic moment. Plastic moment is equal to Z times Fy, which will be equal to 841 times 10 to the power of 3 millimeter cube times 350 Newton over millimeter squared and 10 to the power of minus 6, which will be the Newton times millimeter in the denominator and kilonewton times meter in the denominator. MP will be equal to 294.4 kilonewton times meter. Now we have to calculate elastic lateral torsional buckling moment, MU. MU is equal to omega 2 pi over L square root of E IY G J plus pi E over L squared IY CW. In this formula, we know that omega 2 is equal to 1 because m at any point is larger than the m at the ends, because it is a simply supported member. Therefore, mu is equal to 111.4 kilonewton times meter. Now if we want to compare mu to 0.67 times plastic moment, 0.67 times plastic moment will be 197.2 kilonewtons times meter. It is bigger than mu, so mu, actually we can say mu is lower than 2/3 of a plastic moment. Then resisting moment is calculated by phi times mu, which is equal to 0.9 times 100.3 kilo, 0.9 times 111.4, which will be 100.3 kilonewton times meter. Okay, we found phi 0.9 based on clause 13.1, and these formulas coming from clause 13.6a. Checking against the table. If you look at the page 594, there's a table that will give you the moment capacity for known embraced lengths. So it will give you, for example, for 7,000 millimeters and 8,000 millimeters, it will give you 106 and 89.4 as moment resistance of the embraced lens. If you do the interpolation, MR for 7300 millimeters will be 101.0 kilonewton times meter. As you can see, it is really close to what we calculated here. Now we have to calculate maximum factorial load. If you look at the page 5, 132, you can see that M is equal to omega L squared over 8, which will give us then factor total omega will be equal to 8 times M over L squared, which omega F total will be equal to 15.1 kilonewton per meter. Now if I want to calculate the factorial live load, it will be factor total minus omega factor dead load, so it will be equal to 15.1 minus 1.25 times 0.514, which is self-weight. It will be equal to 14.1 kilonewton per meter. Thank you for listening to this presentation. If you have any question, you can either leave a comment or email me.